we'll see what happens here before the end of the hour. Okay. You guys are all clear on what day stuff is due and how we're going to handle the weather situation that's being thrown on us here. One thing I always thought about here as a math teacher, a lot of times we want math teachers to be correct, right? Yes. And I see stuff like this and I wondered, why wasn't I a meteorologist? Because I've heard anywhere from 2 inches of snow to 24 inches of snow. And boy, oh boy, there are many standard deviations off. Many standard deviations off, aren't they? So my job you can probably be wrong in and still get paid, right? Is that right? Okay. Hey, so again, remind me, what is the perimeter of any shape again? Mary, you told me once. What is it again? The distance around the shape. And then we're also going to talk about area and the coordinate plane. And you guys have already told me that when we're talking about area, we're counting the number of squares on the inside. So I think I've got a great front-loading question before we lead into everything here. There's a lot of stuff that we're going to have to recall from stuff that we've already done this year. But question we want to ask today, or try to at least attempt to answer, is how can you find the perimeter and the area of a polygon and a coordinate plane? Okay. You guys have a distance formula, right? Talks about finding the distance between the 2 points, so don't lose sight of that from the last section. We're also going to have to recall some things about slope here in a bit, but let's kind of take a look at this front-loaded question here and see where we're headed with this. Let's just kind of jump into this a bit. So the front-loaded question, 4 parts to it. Front-loaded question says, is the following a square? Okay. Before I even jump into A, B, C, and D, how about some properties of squares? What do you know about squares, guys? What's one property? Give me a show of hands. What is a characteristic do you know of squares?
It has 4 sides.
It has 4 sides. Okay, so I'm going to write these notes down here. Is the following a square? Let's just kind of define square right here. In fact, I'm going to kind of work backwards here in a bit. We'll kind of come back to D, but it has 4 sides. Very good, Anthony. What else do you know about squares? All 4 sides are equal. Okay. Anything else about squares? All 4 sides are equal. You guys know what a square is. Describe some of the characteristics of it. What's another? Yeah. 4 90-degree angles. So all angles are hey guys, when angles are 90 degrees apart of each other, for instance, the floor and the wall, we would say that forms a right angle or a 90-degree angle, but I would say maybe this floor is blank to the wall. What's another word for 90 degrees? Chelsea, will you get the back door, please? What's another name for 90 degrees?
Right angle.
It's a right angle. 2 lines intersect and form a 90-degree angle. They are, starts with a P. Perpendicular. Okay, all angles are 90 degrees, so I'm going to write this right down here. Adjacent sides are, I use an upside down T for perpendicular. Okay, upside down T for perpendicular. Notes are over there. Okay, so let's get started with this. What question am I trying to ask in this front-loaded part, guys? What are we trying to answer? Is the following a square? Let's check this out. I'm going to volunteer to read part A for me here. Volunteer to read part A for me, please.
Okay.
Thanks, Taryn.
On a piece of centimeter graph paper, draw a quadrilateral ABCD in the coordinate plane. Label the points A, 1, 4.
Okay, so let me do that here quickly. 1, 4.
Negative 3, 1.
Okay, 1, 4 would be right. 1 and up 4, wouldn't it? So right here. What's your next point?
Negative 3, 1.
Negative 3, 1. Oops.
So left 3, up 1. Does that look right? Okay. 0, comma, negative 3, so down 1, 2, 3 right here. All right, my next one. Right 4. Okay, so I'm going to label these A, B, C, and D. I'm just going to sketch this in here real quickly. Do my best to sketch this.
You want us to
Yeah, go ahead and draw that way, don't you? I'll do my best to sketch this. That didn't work out very well, did it?
No.
So my first question is, does this look like a square, number 1?
You want us to draw that?
Yeah, go ahead and draw that. I'll make sure I have all the points again. 1, comma 4, right 1. Got that. Okay, first things first. When I sketch that, does that appear to look like a square, maybe? I don't know. Does it look like it for you guys? Not quite, okay? First thing they're asking us to do, so we've already gotten this drawn. I'm going to write down C below. Part B, the next thing they ask us to do is to find what, kiddos? Find the what? Perimeter. So I've got to find the distance around all sides, okay? Now, I'm going to be a nice guy. Today. Your distance formula, we're going to use a program to do this. So what I want you guys to do is this. Maybe get into your Chromebooks quickly, and just going to type this in. Distance formula calculator. Okay, so Google that up, distance formula calculator. Okay, and then click on that first link. Are you guys there? Okay, are you where I'm at? Okay, I'll give you some time to get there, so take a minute and do so. All right, so what we're going to do is we're going to find the distances of all 4 sides. So right here, gang, what I'm going to do, these 2 side by side, and we're actually going to find the distance from A to B. So gang, right here, what point is A? 1, 4, and B is what? -3, comma 1. Okay, so let's go into our calculator here, and let's put our points in. Okay, I'll show you how this works. Point 1 right here. So it was, what was it? 1, comma 4, is that right? Okay, positive 1, comma 4, wasn't it? And then the next point was -3, comma 1, is that right? Alright, so if it doesn't like that, just go like this. Use your arrow to get to -3, comma 1. Are you guys there like I have that in here? 1, comma 4 up top. Negative 3 comma 1 on the bottom.
Yep.
Now if this is a square, what should be true about all lengths, guys? It should be the same. So we're going to go ahead and calculate this. And what value do I get right there from A to B? What value do you end up with?
5.
Got right down here, it is 5. So what you'll want to do is go ahead and put a 5 up there. From A to B is 5. Okay. So let's do the next one. You guys punch your numbers into this formula right here and tell me what the distance is from B to C. So you're going to put your B value in as negative 3 comma 1. What are you going to put in for the next point, or the second point down here from B to C? What are you going to plug in there? 0, negative 3. So I'll make sure we've got... put the 0 here and then the negative 3 there. So you might have to scroll down or put the arrow down as an option. Type in negative 3, see if it works. Something like that. That's weird. There we go. Put down 0, put 0, negative 3, 0, negative 3, and then negative 3 comma 1. Okay, so you're putting in the 2 points, B and C. Put in B and C. So I'll see if I agree with you guys. Again, B is the point, negative 3 comma 1. Yeah, I don't like this. It doesn't take negative very well, does it? Negative 3 comma 1 and 0. What do you guys get for that distance? 5. Okay. Who would do the distance from C to D for me?
It's 5.
It is 5. How about this distance?
It's 5. They're all 5.
They're all 5. That's the worst looking 5 I ever wrote. So by our definition of a square, are all sides the same so far? Yeah, so far so good, right? 4-sided figure, all sides are the same. I guess the only thing we need to check out now is to see if the adjacent sides or one side or each corner is how many degrees, guys?
9.
Let's check this out. Okay, so I'm going to go to part B. It says find the perimeter of quadrilateral ABCD. Guys, help me with perimeter. What's the distance going to be around here then after I use that distance formula calculator to find them? 20. Yep, the perimeter is going to be 5 plus 5, which is 20 there. Guys agree? Everybody agree? Then here's the deal. Are adjacent sides of a quadrilateral ABCD perpendicular to each other? Question is, how can you tell? I'm going to ask you this question right here. Remember your definition of a slope? Remember your definition of a slope? What was it, McKenna? Yeah, no? Something over something. When we talk about, yeah, it's a rise over a run. Everybody agree with that? Rise over run? Okay. If we had what we called two lines that were perpendicular to each other, perpendicular slopes were the following. They were, first word's opposite. Anybody remember the second word of two lines that are perpendicular? Two lines are said to be perpendicular to each other if their slopes are opposite lengths of each other. Opposite reciprocals. Great, Taryn. Opposite reciprocals. So just a quick refresher from what we did a long time ago. If the slope of a line is 2/3, if the slope of a line is 2/3, what's your perpendicular slope? What's your perpendicular slope? You have a line that's 2/3 in a coordinate plane. And I want to know know what the slope of a line that would be perpendicular to that would be. So what do you do with the 2 over 3? Flip it around. Since this was positive, the perpendicular slope must be negative. Let's check this out. Perpendicular slope then would be negative 3 over what? 2. Okay, so I would say 2/3 is an opposite reciprocal of negative 3/2. So if you have opposite reciprocals of lines or line segments in the case we're about to look at, you'll know that those lines are perpendicular or form 90-degree interior angles. So as we look at part C, are the adjacent sides of quadrilateral ABCD perpendicular to each other? I'm going to talk about angle A, angle B, angle C, and angle D in this example. All right? So let's count. I'm going to get a different color up here to count our slope. So let's do the slope of AB. I'm going to count rise over run. So to go from this point to this point, looks like I have to go up 1, 2, 3, and over 1, 2, 3, 4. I was going to do that in a different color. Oh, blue. Okay, so the rise over run right there, kids. Rise over run. How far did I rise up? 3. And how far did I run? 3/4. So right here I'm going to put an arrow. I'm going to say M equals 3/4. M is the variable we use for slope. Okay, so at angle A and at angle B, adjacent sides, if those angles A and angle B are going to be right angles, then what does the slope have to be to form a 90-degree angle? In other words, what's the opposite reciprocal of 3/4 here? Negative 4 over 3. So for this segment right here, from A to D, I want that segment to be an opposite reciprocal 3/4. And right here, that segment BC, I want that to be an opposite reciprocal 3/4. So let's check this out. Let's do the rise over run for this side. Looks like I would rise up 1, 2, 3, 4, and then run back to the left 1, 2, 3. Now when I run back to the left like this from C to B, is that a positive change or negative change when I'm moving left? And by the way, this B to C line, is that an uphill line or a downhill line segment? B to C, uphill or downhill? Meaning that's going to be what type of a slope? Negative, you bet. Okay? All right. So the rise is 4 here. The run's negative 3. So this slope is negative 4 over 3. Is this an opposite reciprocal to this? Don't have to. Is that an opposite reciprocal to that? It is. So what's that mean about angle B? How many degrees, guys? Angle B is 90 degrees, right? Same thing with this slope. Up 4, back 3. Rise of 4, run of 3 right there. From A to D, is that slope positive or negative? A to D, is that slope positive or negative? Ah, it's negative, isn't it? It's downhill again. Okay, so that makes angle A right here. This slope right here is negative 4 over 3. Isn't this right here an opposite reciprocal to that side right here? So that makes angle A 90 degrees. Okay, what's the slope of this last line that I haven't looked at? Looks like a rise of how much? Looks like a rise of how much? Looks like a rise of 3 and a run of how much? 4. Rise 3, run 4. Okay? Slope here is 3/4. Is this 3/4 an opposite reciprocal to the other sides adjacent to it? It is. What's true about all your angles then? They're all 90 degrees. They're all 90 degrees, you bet. So, in part C, are the adjacent sides of quadrilateral ABCD perpendicular to each other? The question is, how can you tell? How can you tell? We look at slopes. I'm going to say the following. Slopes are opposite reciprocals of each other. They're opposite reciprocals of each other. Okay, so we have a four-sided figure. We have a four-sided figure where all four sides are equal. And we know all four angles are 90 degrees. So in part D, the question becomes the following. Is this a square? Yes or no? Yes, it is. And then the part of it says, how do you know? Yes. Well, what was true about all four sides? What was true about all four side lengths? They're the same. We found that using that distance formula calculator. So all four sides are the same. All four sides are the same. And then, what do we know about all the angles? What do you know about all the angles? They're the same because each side that's adjacent to each other, the slopes were what of each other? And we learned a long time ago that if you have two lines where the slopes are opposite reciprocals of each other, then you have a 90-degree angle, or perpendicular lines. Okay, so all four sides are equal. All four angles are 90 degrees. Okay. So, I would say in a nutshell, make sure you have that down because you're going to be asked to justify some stuff today. And this is just kind of a jump-in type of a question in terms of where we're going today. I know when I drew the thing, it looked like a square, didn't it? When I drew it right away, didn't it look like a square? Did we know it was a square after I drew it? We're not 100% sure. We had to justify some things. We had to make sure the sides were equal and make sure the angles were equal. But were we able to justify all of that? Okay. So, to kind of jump into this, was the figure a square? Yeah, we did a lot of work to prove that it was. Okay, and when I got done here, it looks like a complicated football play right here, doesn't it? Right? Where are my football players? This looks like a little curl route right here, right? Right? They call like a little hook and ladder route anywhere in there? Can you find a hook and ladder route in there? No?
Negative 430.
Something like that. Looks good, right? Okay. I was going to say, since it's Valentine's, it looks kind of like a goofy Valentine's Day heart in a way. But
Drawing like a heart for like a first grader.
what's that?
It's like a first grader tried drawing a heart.
Fortunately for me, first grade art is probably better than mine. Okay. All right, so let's jump into this. Let's get going with this today again. Again, how do you find area? How do you find perimeter of anything plotted in the coordinate plane? That's what we're going to look to try and answer. So goals for today is this. We're going to classify polygons. I would assume you know the names of these. Three-sided figures called what? Triangle, right? Four-sided figures, quadrilateral. Five-sided, what's a five-sided figure? Pentagon. Six-sided? Hexagon. Seven. Anybody know seven?
Oh gosh, I feel like I know.
Seven, there's two different names for it. You can call it heptagon, H-E-P-T-gon, heptagon, or some people call it a septagon. Okay? Heptagon or septagon. 8 sides. Octagon. Now you see people know that, right? Okay, how about a 9-sided one? Anyone know what a 9-sided? What is it? Nine-tagon. It's called a nonagon. Alright? Nonagon. Anyone know what 10 is? Decagon. Now once you get past 10, they start going typically 11-gon, 12-gon, 13-gon, 14-gon, which is typically not right, but they just make it easier for you. So if you get to a 26-sided figure, call it a 26-gon. Okay? 26-gon. Okay? We're going to talk about inscribing regular polygons. I'll show you what that means. And then the last one, the most important one today for us guys, look at fine perimeters and areas of polygons in the coordinate plane. That's going to be big for us today. If we can meet that goal right there, we've answered a lot of questions. Okay? So some quick vocab before we get into the notes. And like I said, we may or may not get done with this today, but let's give it a shot. Okay, a polygon. Volunteer to read what a polygon is for me. Help me out. Any closed shape with straight edges. So here it is. Maybe something like this. I don't know. All right, draw a rectangle. Okay. Are my edges straight? Are my edges straight?
Yes.
Okay. Is it closed? Meaning the start point and the end point are in the same spot?
Yeah.
Okay. Side is going to be any segment of a polygon. You know that. Vertex. Vertex is the corner of any polygon. So right here, if I draw a triangle right here, how many vertices do you have? How many vertices do you have? Three. If I call my vertices, what vertex did I label there? A. So vertex A. Any vertex is just a corner of a polygon. Okay? N-gon is just the number of sides a polygon has. Now you know the basically 3 through 10 names. So I won't get too worried about that. Guys, the two that are kind of important, we're going to talk about convex shapes and concave shapes. Convex shapes and concave shapes. So, what's that? Yeah, those are pretty important. They're going to ask you to identify if a shape is convex or concave. I've kind of added my own definition to what they may have in terms of books there. So, right here, convex shape is going to be something like this. The word or the phrase I put in here, not dented. If you can think of something as not dented, in other words, all segments lie inside the polygon. If I would draw a shape, say like this. Let me draw this quickly. Okay, there's my shape. By the way, how many sides to that? Looks like 1, 2, 3, 4, 5, 6 sides to that. What's that called? 6-sided. Hexagon. Very good. Convex means the following. It means I can choose any 2 points inside of that shape, no matter where I choose the 2 points. Let's say I choose a point maybe here and here. Okay? The 2 points I've chosen right there and there. If I draw a line segment between those 2 points, does that line segment travel outside of that shape at all?
No.
It doesn't, does it? Okay, let's make sure we're paying attention, all right, guys? It's not easy. Same thing here. If I choose 2 different points, say maybe here and maybe up here, and draw a line segment in this.
Isn't that only 5 sides?
6 sides. See it?
Yeah.
No matter where I choose 2 points in there, will that line segment ever travel outside?
No.
No. So if that happens, if that's the case, it's not dented, we say. It says all the points, if you draw line segments inside of that, will always be inside. Now something that's concave is going to be very opposite of that. It's going to be a situation where, hey, you draw a shape, looks like this, kind of like this. If I would pick a point here, and maybe a point right here, and draw a line segment from point to point, what happens to that line segment right there? It travels outside of it. So I always think of concave stuff as like caved in. It's dented a little bit. In other words, when I draw a segment from one point inside the figure to another point inside the figure, the line segment does not necessarily stay within that polygon the whole time. All right? Doesn't stay in there the whole time. So, what you want to make sure of is, what does convex mean? Concave. What do they mean? Do the illustrations help you understand that? Illustrations help you? Outline of this eraser, concave or convex? Outline of this eraser, concave or convex? Convex, right? Okay. How about the outline of this gear right here? Concave or convex? Concave, because if I pick a point here and here, won't that line travel on the outside of that? Okay, very good. Very good. And then the last one, a regular polygon. A regular polygon is any polygon with all sides equal in length and all interior angles are equal. All sides equal in length. All angles on the interior are going to be the same. So right back here, guys, this square, were all sides the same? Were all sides the same here? Were all angles equal? So is that a regular polygon? Yes, it is. Okay. All right, let's jump into the next page 3. Classifying polygons. This is supposed to be closed right here. I don't know why it's not. So draw that in there. Make sure you close that all the way right there, okay? Close that side right there. Yours is? Okay. So the question becomes this. Classify each polygon by the number of sides. Tell whether it's concave or convex. Let's do the first one together. First of all, guys, how many sides to this shape right here? How many sides are there to this shape right here? Count. How many sides? There's 5 sides, right? So what shape are we going to call that? 5-side figure. What do you call that? Pentagon. Okay. Next question then says identify it as concave or convex. What do you want to say there? Is it dented or not dented? Well, it is, but if I pick points inside here, are they ever going to travel outside of that? No. So is it concave or convex? Convex. This would be a convex pentagon. Okay, how many sides to the next shape here, guys? How many sides there? 6 sides, making it a hexagon. Concave or convex here? Concave. Okay, tell me where to draw 2 points so that we can illustrate that a line segment would pass on the outside or the exterior of the polygon. Describe to me where to draw those. I'm going to pick 2 points here and here. Segment's in there, therefore it's concave, right? Or I'm sorry, convex. That little segment stayed in there, didn't it? Is every segment going to stay in there? Describe to me where it might pass outside of that shape. By the 1 up here, and where else? Maybe down here? If I draw that segment, oops. Houston, we have a problem, right? Okay, I could never say that when Houston Freeman was in class. So I'm glad I could say that now. Because I would say, Houston, we have a problem. Like the radio back to NASA, but he was in class, he would think he had a problem. Anyway. Concave or convex, kiddos? And then 6-sided was, you told me I believe hexagon, right? Okay. All right, so good. So make sure you understand how to name stuff. That's what example 1 is all about. All right? Okay, so let's start looking perimeter and area. This is the big part today, starting at example 2. Finding perimeter, finding area. Recall a couple of things. Recall areas of triangles and parallelograms. I want to write this down for you. Area formula for a triangle. Be base times height. Since it's a triangle, you have to cut it in what? What do you do with triangles to find the area of it? Cut it in half, you bet. Parallelogram, simply a base times a height. So I want to recall those because this is going to be pretty important in terms of knowing how to do this. Now gang, you remember that calculator I told you to open up here? Sometimes you're going to be looking for lines that are slanted, not necessarily horizontal or vertical. Your job is to find distances here. I would say use that calculator to find some distances. So, it says find the perimeter of triangle PQR with vertices -1, 4, 2, 4, 2, -1. Why don't you guys take a minute and plot that. Go ahead and plot that triangle. Why don't you guys see if you can't use your resources here to come up with a perimeter. Just a perimeter, so distance around this, okay? So you guys go ahead right now on your own. See if you can get that plotted, draw that shape in, and then if you have any horizontal or vertical distances, count those. But if there's anything that's slanted, not horizontal, not vertical, in other words, you can use your distance formula calculator to find that side. So I'm going to go ahead and work on this. You do the same. And guys, when you're rounding stuff, let's go nearest tenth on everything. So if you're looking for a distance, go nearest tenth. So if the calculator kicks out like 4.71, call it 4.7. Okay. Okay, just looking at my drawing right there, does that appear to be what you guys have drawn, first of all?
Yes.
Okay. I was able to label P, Q, and R. I can count this top distance. It's just horizontal, so it looks like to me that was 1, 2, 3 units. And then Q to R is 1, 2, 3, 4, 5 units. My problem is that I don't have this distance right down here. Okay? Is this a vertical or horizontal line from P to R, guys? Is it horizontal or vertical at all? Is this line vertical or horizontal at all?
No.
No, it's not, okay? So I want to find the distance from P to what? P to what? R, P to R, okay? So get into your calculator right now and punch those points in, the ones that I underlined in blue, and tell me what that distance will be.
5.8.
Okay, what'd you have?
I have 5.83.
5.83, so we'll call it 5.8, all right? 5.8. So again, we're identifying the perimeter. So right here again, if you have a slanted side anywhere, figure out what those points coordinates are, plug them in, get that distance. So the perimeter of this right here, P, help me out here guys, what plus what plus what? Go ahead again, Jacob.
5.8 plus 5 plus 3.
Good. And what's that equal, kids? What's that going to equal?
13.8.
13.8. Excellent. 13.8 units about. Okay. So that came from this calculator. Okay, my point P right here, I plugged in -1, 4 up here, so I want -1, comma, -1, 4, right? So I bumped that up, and then I'm just going to back this down. Okay. And then the other point right down here is right 2 and down 1, right?
Right 2, so
Thank you. 2, -1, right? See it there, Mary? Okay. So that's how. So any diagonal, that's what you would do. Okay? I gotta look at this and say, you know what, it's a right triangle also, couldn't I? What's 3 squared?
9.
What's 5 squared? 9 and 25 add up to 34. Square root of 34 is about, you okay with that? Okay. So that's where that came from, kiddo. All right, very good. All right, let's jump into this last page and see where we land. So here we're going to look at finding the, area. Okay, we're going to find the area. How many square units are on the inside of this? All right, and this is not bad to do. Not bad to do at all. Find the area of triangle ABC with vertices 1, 3, 3, -3, and -2, -3. Go ahead and plot those quickly, all right? Plot those quickly. I'm going to do the same. All right, how about my triangle? Does that look like I've plotted correctly? Okay. So first things first, guys, what am I trying to find the area of? What kind of a shape? A triangle, right? A triangle. So what's the area formula for any triangle, guys? We recalled it already. What's the base, or I'm sorry, the area formula for any triangle? Come on, guys. Base times height divided by 2. All right? Let's see, I could use this as a base length right down here at the bottom. And I can say my height is on the inside here, straight up and down. So you guys count, what's the base length? Count your base length on your chart. Looks to me like 5 units. Do you guys agree? So the bottom base right here is 5. Okay, from the bottom to the very top, then how high up are you? Looks like 6, isn't it? Height of 6. So my base is 5. My height is 6. Base is 5, height is 6. I can find the area, kiddos. Anybody? Divided by what? So 6 times 5 divided by 2. Okay. Some of you guys, I'm a little worried about taking some plays off. And basketball is not good. Taking some time off in math is not good either. Okay, so this will be 15 square units. Okay? 15 square units there, all right? So that means this, if I would shade one of these squares in here, and I could count, and there's again part of these in here that are shaded or not completely full, but that one shaded square in there, how many of these shaded squares would it take to fill up this shape? How many would it take to fill that up? 15. Okay, 15. All right, I think, for example, let's try and get this perimeter nailed down. The area, I'll kind of describe to you the area here. We're not going to get to that all the way here before the end of the hour, but take a minute and go ahead and plot that figure right now. Go ahead and plot those points. And then connect your points, connect segments in order from A to D, and then close that back up and get your shape. So I'm going to do the same while you're plotting this. So A is 4, 5. All right. I want to get the perimeter of this done, and then we'll stop there today. Do you guys agree with the shape I've drawn up there? Everybody agree with that shape? Okay. There's no horizontal or vertical lines, so where are you going to go to find your distances of each side? The calculator, you bet. All right, so I need somebody to find that distance from A to B. Plug in your point A and plug in your point B and get a distance. Who will do A to B for me? Jacob, you got that. Who's doing B to C for me? McKenna, you've got B to C. Make sure you're plugging in the right points up here. Who's got C to D for me? Who will plug in C to D? I need a volunteer, someone different. Karen, will you plug in C to D for me? Yeah. Okay, make sure I'll put you down here. John, you want to do D back to A for me? Okay. Okay, when you've got your decided by plugging them into the calculator, so make sure you know which points you're plugging in. Jacob, you had A to B, McKenna B to C, Taryn C to D to plug in, and then John D back to A or A to D. Okay, when you've got your distance, let me know. Jacob, how much were you?
5.099.
So we'll call it 5.1, and we'll round to the nearest tenth on that. So I'm going to call this about 5.1. Anybody else ready? McKenna, for your side? 5.8. You're all right. You're all right. Make sure you're putting C and D in there as points, okay? Just 5? Excellent. 5. I agree, Taryn. Good job. John, have you got yours, bud?
Yep, 8.1.
How much?
8.1.
8.1. All right, so we found each side using that calculator. Once you know all 4 sides, what are you going to do to simply get your perimeter? Add them all up. So your perimeter, add them all up. So let me write this down. Perimeter is going to be 5.1 plus 5.8 plus 5 plus 8.1. And I think nicely this turns out to be a perimeter of, is it 24? 24 units, I think that adds up to 10.9, 15.9, 16. Yep, your perimeter is 24 units in length, okay? 24 units long, okay? All right, I'm going to go ahead and stop there.